Hello there and welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at the types of special triangles. Here are the lesson objectives we would want to achieve by the end of this lesson. Without much ado, let's quickly look into it. So to start it all, what is a triangle? When we say a polygon is a triangle, what does it mean? So we can say a triangle is a polygon with 3 sides. Or you can say with 3 angles or with 3 vertices. Now, you know what a polygon is, any close-sided figure. So if you draw any close-sided figure, and then you realize at the end of the day, it has 3 lines, then we can say it is a triangle. You see? So it is from the word triangle, tri meaning 3, and then you have the angles. So if it has 3 angles, then it's the word a triangle. So as you can see, this is a triangle I have drawn over here, and you realize that talking of sides, it has 1, 2, and then 3 sides. You see, and talking of angles, it has an angle over here, it has another angle over here as well, and then an angle over here as well. And then talking of the vertices, we have a vertex here, another one here, and then another vertex over here. So this is what we call a triangle, and that is what we are coming to look at in details in this lesson. Now, talking of the classification or the types of triangles, we'll be looking at 2 main classifications. That is the classification based on the sides, and then the classification that is also based on what? The angles. You see, so based on the number, the sides, how the length of the sides, and then the measure of the angles, we have different types of names we give to these triangles. So we'll start by looking at the classification by sides. Now, under the classification by sides, we have 3 types of what? Triangles. So we have the equilateral triangle, we have the isosceles triangle, and we have the scalene triangle. So we'll look at all these 3. Let's start with the equilateral triangle, and as we explain, you take note and then know the difference. So let's start first of all with what we call the equilateral triangle. You see, so the equilateral triangle is what you are seeing on your screen. What are the features or characteristics of an equilateral triangle? Equi here simply means equal, and lateral simply means lines, right? So we are talking of equal lines. So we can simply say an equilateral triangle is a triangle with all of its sides equal. And what we mean by all of its sides being equal is this red line here is equal to the blue line, and it is also equal to what? This yellow or golden line we see over here. So the first classification, which is by sides, is that if all the sides are the same, then we can call it equilateral triangle. As we proceed, you'll get to understand that for an equilateral triangle, since the sides are all the same, then we can also say that the angles we have in here are also what? The same. So all the sides are the same, and that results in what? Having the same angles. So anytime you see an equilateral triangle, or if you see any triangle at all, and there are these lines on it, so you have this over here, and then you have this as well over here, is to tell you that the lines are the same. The measure of the lines are the same. So with that said, let's look at an isosceles triangle. What is it? Now, the next triangle we want to talk about is what we call the isosceles triangle. So for the isosceles triangle, unlike the equilateral triangle, we say it has 2 of its sides being the same. So as you can see, it has been indicated with this line, this double lines you see. Since this has double line and this also has double lines, it means they are the same, but this has just 1, you see. So isosceles triangle has 2 of its sides being the same, and the other one's length is different from the other 2. Now that results in we having, if this is the base, then for the angle alpha here, and then beta over here, and we have another angle, let's say a gamma. That will result in alpha being equal to what? Beta. So it simply means the two base angles are the same. It has two angles that are the same, but then this angle here would be of different measure. So for isosceles triangle, once again, it has two sides being the same, resulting in two angles being the same. Unlike the equilateral, where we said all the sides are the same, and then resulting in all the angles, so alpha being equal to beta being equal to gamma. Isosceles has just two of its angles being the same, resulting in two sides also being what? The same. Now let's consider the last type of triangle, which is classified based on the sides. For this last type of triangle, we call it the scalene triangle. Scalene triangle, unlike the other two, has all the sides of different measure. So the measure we have of this side, the red one, is different from that of the blue, and they are both different from that of the gold, you see. Now that also results in all the angles being different. So if I have alpha here as my first angle, and then another angle here, let's say beta, and then another one here being gamma, that simply means alpha is not equal to beta. And then the measure of both are also not equal to what? Gamma. They are all of different measures. And that is what we call the scalene triangle. So no sides are equal, and also all the three angles are different. Let's then look at the classification of triangles based on the angles, the measure of the angles. So before that, let's note classification based on size. We have equilateral, which means all the sides are the same. We have isosceles, which means it has two sides being the same. And then we have scalene, which means no sides are the same. Now, when we talk of classification by angles, we have three of these types as well. So we have the right angled triangle, we have an acute angled triangle, we have an obtuse angled triangle. These are very, very simple. So let's first of all look at what we call the right angled triangle. So talking of a right angle, it is as you see on your screen. A right angle simply means that, so right angle simply means 90 degrees. Okay, so if a triangle is said to be a right angled triangle, it means exactly one of the angles measure is what? 90 degrees. And that is what we see over here. So this here is indication of what? 90 degrees. Now you can even take your protractor and then measure. You realize that it's actually a 90 degrees. So anytime we have what? One of the angle being what? 90, we are saying it's a right angle triangle. These other angles can be what? Any measure. You see, they can be what? Any measure. Now you can have a right angle triangle which is isosceles. You see, the reason being that this measure can be the same as this measure, but then the three can never be the same. You see, so you can have an isosceles right angle triangle. Now, most of the times we apply theorems in what? The right angle triangle to solve problems. One being the Pythagoras theorem. The Pythagoras theorem allows us to name this longest side the hypotenuse, and then there are formulas we use to solve all of these. Other application of a right angle triangle is that of the SOHCAHTOA. So in our subsequent lessons, we'll consider all of that. The next type of triangle is an acute angled triangle. So talking of an acute angled triangle, let's take note of this. So if you have an angle over here, let me call this angle an alpha, and then a beta, and then gamma. Now, if all these angles measure are less than 90 degrees, then we say we have an acute angle. Remember, an acute angle is just any measure of an angle that is greater than 0 but less than 90 degrees. Hence, we can say that if alpha is what? Less than 90 degrees. And then beta is less than 90 degrees. And your third angle, the gamma, is also less than what? 90 degrees. Then we mean the angle is a what? An acute angle triangle. That is just it. So take note of your angle. If they are all what? The angles, if they are all less than 90, definitely your triangle becomes an acute angle triangle. Now, talking of an obtuse angled triangle, an obtuse angle is an angle that is simply greater than 90 degrees but less than 180. So if you're able to construct or draw a triangle such that one of the angle is more than 90, you have drawn an obtuse angle. So if you observe what we have over here, this angle, this particular angle is what? Is greater than 90 degrees. And it is as well less than 180 degrees. Since we take note of this, then it simply becomes an obtuse angle triangle. And this is the third type of triangle we need to take note of. Now, with all these triangles, there are some that can be from both classifications. You can have an obtuse angle triangle that is isosceles. You can have an obtuse angle triangle that is also a scalene. You see, so you take note of the properties and try as much as possible to identify based on what you see or the characteristics the triangle has. So we close docket on classification of triangles. And now let's look at similarities and then congruence. We'll just talk a bit about it. Now that we know what all these triangles are based on their classification, it is important we take note of how to know or determine if two triangles are similar or congruent. So let's start by first of all looking at what congruent triangles are. Now, if we consider these two triangles I have, this here is triangle ABC, and then this here is also triangle what? DEF. Now it can be anyhow, right? Okay, but then on the safer side, let's maintain them this way. Let's take note of something. If I'm to take triangle DEF and superimpose it on what? ABC, what do you see? Realize that they are exactly the same. That is, this side is equal to this side is also equal to this side, and then this side is also equal to this side. That is what we call congruence. So when you superimpose and then they look the same, we say they are congruent. Hence, what are congruent triangles? Let's write something. So for congruent triangle, it simply means they have the same shape and then they have the same size. Talking of the same shape, if this one was to be an equilateral triangle, this would also be an equilateral triangle. If this was to be an isosceles triangle, this would also be an isosceles triangle. If this was an acute angle triangle, this would also be an acute angle triangle. They will have the same shape and their sizes will be the same. You see, so this side here will be the same as this side here. The blue will be the same as what? This yellow. This would also be same as what? This one we see over here. That makes them congruent. Secondly, all corresponding sides are what? Equal, and angles are also equal. So this angle here will be the same as this angle. This angle will be the same as this, and then this will also be the same as this. We call them corresponding sides, and then what? Angles, they are equal. If that happens, we say the angles or the triangles are congruent. Now, there are rules we use to determine if whether or not two triangles are congruent, but then that is beyond the scope of this lesson and we wouldn't talk about it. But for triangle ABC and then triangle DEF, if we are saying they are congruent, this is the symbol for congruence. How do we write it? You just write an equal to and then you do this on top, this wave on top. That is what we mean by congruence. Now let's look at two triangles that are said to be similar. Let's take a look at these two triangles once again, and you would realize that they're a bit different from the previous one. This looks bigger than this, you see. And if I'm to take this smaller one and then I scale it, so if I'm to expand it this way, you'd realize that it would fit perfectly into this. You see, it fits. So let me just put it as it was. The same way, if I'm to take this as well and then scale it downwards, realize that it will also become equal to what the previous one. So do you know what that means? It simply means that one of the triangle is a scaled version of the other. You see, they are proportional to each other. And you'd also realize that they are of the same shape. So this is an isosceles and this also becomes an isosceles. These are what we call similar triangles. Hence, when we talk of similar triangles, then it simply means they have the same shape, but then they have different sizes. You see, so as I said, equilateral, equilateral, isosceles, isosceles, acute, acute. You see, the same shape, but then the sizes are different. One is smaller and one is bigger. Secondly, for corresponding angles, the angles would be equal, all right. All the angles we have would be equal, but then the sides are proportional. One is a scalar of the other. That is what we mean by what? Similar triangles. Unlike congruent triangle where they are actually the same, everything is the same, they are strictly the same. For similar, what do we say? They have the same shape, all right, but different sizes. They have the same angles, all right, but different sizes. So just as we have a nice symbol to illustrate congruence, we also have this for what? Similarity. It's just something like this, a simple wave for what? Similarity. So these are the two concepts you need to understand with regards to what? Triangles. That is congruence and similarity. So we can sum it all up by saying that for congruent triangles, they have the same shape and then size. But for similar triangles, they have the same shape only. The emphasis is on shapes only. The time is far spent, and then I wouldn't add up by solving some questions. But then, as usual, I'll leave you with some exercises. So you try on your own just to test your understanding. So here are questions. There are just 5 of them. You can try to test your understanding on the concept you have learned. If there's any issue of concern, you can always let me know at the comment section, and I'll address that when I'm notified. This Hub Beyond Numbers where we learn maths the easy way. If this was your first time on this channel, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and stay blessed. Stay blessed.